how to set a foundation of quality here on Programming with Palermo.
You are programming with Palermo. You deliver software. You need to move fast, deliver quality, and run your software with confidence. Stay tuned for timeless solutions, simple methods, and topics that will propel you forward. And now your host, lifelong programmer, author, teacher, coach, Christian, and charismatic speaker, Jeffrey Palermo.
Welcome back to Programming with Palermo. I'm your host, Jeffrey Palermo, and today we're going to talk about how to set a foundation for software quality. You're an architect. You are responsible for leading a group of software engineers to achieve the ability to move fast, to deliver quality, and to ultimately run your software with confidence in a production environment for your customers. But we're going to talk about where software fits in that order, how you should think about quality, and ultimately how to organize it in with your team. So let's get into it. So let's dig into the foundation of this, how to set that foundation of software quality, and how do you achieve software quality as an architect overseeing a team. Now, when you research software quality, you quickly run across the published research by Capers-Jones, and one of his findings is that the cost of finding and fixing bugs or defects is the single largest expense in the history of software. You got to find them, you got to fix them. And he's also extrapolated from research that over about 25 years, a typical large .NET software system that's about 500,000 lines of code, 500,000 lines, almost half of every dollar spent on that software team will be spent finding and fixing bugs. And if you want to compare your team's quality with the industry average, then you can use his research to do that. And I'd encourage you to do that. He's probably the most prolific researcher and publisher of research in the software industry. But let's talk about software at a high level right now and where you should fit that into your thinking. So for many, many years, the discussion of quality has come out of discussions of testing. And in the software development lifecycle, testing has always been sequenced after the programming of the code. After all, you can't test some code that doesn't yet exist. That just makes sense. But the conversation has expanded over the years from testing to overall quality, but it still hasn't fixed the sequencing. It still hasn't been placed properly in the software development lifecycle. So let's organize the concepts in the order of actual dependency when you're putting together or running a software team. So in the last episode, I talked about moving fast, productivity. You as the architect, how to achieve the good speed and productivity that you want out of your team. This episode is on quality. And next week, we'll cover running your software systems with confidence in a production environment. But this week, we're going to focus on quality. Now, let's talk about the relationship of moving fast and delivering quality and running your software systems with confidence by achieving stability. The proper order or dependency on order is quality first, then stability, and then velocity. Before achieving quality, a significant percent of the development team's capacity is stolen away to find and fix defects. And you think you have a certain number of software engineers that have a certain amount of time, but a significant percent of that time is just fixing problems. Before achieving stability in production, also a significant percentage of development capacity is stolen away from the team to find and fix issues that cause the software to be unstable in production. Those random errors, poor performance, crashes, etc. Things that only seem to happen in production. You don't really reproduce them in a UAT or pre-production environment. Now, if you attempt to have your team move faster without achieving quality or stability, then you will also not achieve productivity or the speed that you want. And you'll actually end up achieving none of the three. Now, as far as analogies go, I compare it to starting a family, buying a house, a car, or otherwise increasing your expenses without first finishing an education that will yield you work in a field that will support a certain level of expenses. Now, certainly you can borrow some money and buy a house and and put money on a credit card to buy other things, but the interest that you pay on the debt will right away steal a significant percentage of your earnings capacity, making it even more difficult to achieve balance. And this is kind of the origin of the term technical debt. The interest that's charged is kind of like a tax on your team's work capacity.
Programming with Palermo is brought to you by ClearMeasure, a software architecture company that empowers .NET teams to be self-sufficient, moving fast, delivering quality, and running their software with confidence in Azure. If your team has a project that's too important to be delayed or derailed, ClearMeasure can help, while keeping your team in the driver's seat and growing in capability. Click on clearmeasure.com for more information. If you are an architect or .NET engineer aspiring to become an architect, check out clearmeasure.com/careers. Now, back to the show.
And let's take a break and talk about just the level of these costs, the magnitude of the problem. Now, there's been plenty of research on this topic. One study found that 13 hours is an average amount of time spent by a software engineer to find and fix a single defect once it's deployed to production. Some other clever analysts tallied up 620 million hours in a software team spent on debugging software failures per year. And the data that you can find definitely shows that early detection minimizes costs. And that's actually been around for a long time. Early detection in any industry, early detection of a problem minimizes costs. And prevention is even better than that. But if you're an architect responsible for the performance of a software team, what do you do? What does this all mean? So in any new team and in any new project, or even if you're in a mess now and you have to first focus on the mess you have in front of you, the first thing that you want to do is achieve quality. That needs to be your first thought, not the new technologies that you've never used, not this new pattern that you're eager to try out, not going fast and trying to crank out a good number of features right out of the gate to impress somebody. No. You need to first achieve quality, because only then will you have an actual firm foundation to go forward on anything else. You'll also do well to check out Capers-Jones's 2012 article, Software Defect Origins and Removal Methods. You can also check out another article, 2016, and the title of that is Exceeding 99% in Defect Removal Efficiency for Software. And we kind of base some of our findings on that published research. But I'll summarize to lay a level playing field here. The 3 essential defect removal techniques across all of the research, you can boil it down to what are the 3 that you have to have from the very beginning of a new team, very beginning of a new project, or just right now if you're starting in the middle of a mess and you've inherited a team, you've inherited a software system. The 3 essential defect removal techniques are static analysis, testing, and inspections. So what is static analysis? Essentially, it's command line tools that analyze the code and tell you about problems. And there's really good tools out these days. You want to analyze all the code, all the significant languages. There's the JetBrains ReSharper command line. There's the Microsoft Roslyn analyzers. There's Independ. There's SonarQube. There's TSLint for TypeScript, if that's significant in your code base. There's the Wave toolbar for accessibility of HTML markup if your applications need to be ADA compliant or compatible with screen readers. There is a whole litany of static analysis tools that will look at the actual source code and tell you about problems. And those problems are going to be largely the source of defects. And so right off the bat, you can fix problems even before you run the software. So put those in place, and it's up to you to determine what is a significant language. If you have a significant amount of SQL code for stored procedures, then you want to use one of those tools. Now, if you're using an OR mapper like Entity Framework and you're generating all of your SQL, then you probably don't need a static analyzer for SQL. But you have to determine what your significant languages are and get a tool integrated into your integration build for that. The next one is testing. So let's break that down. And by the way, manual testing never suffices. You can never go through all the different scenarios in a piece of software to know that everything is working as it should be. Automated testing is better, but test-driven development with at least 3 levels of test suites should be your target. This prevents defects as well as removes defects when you make a change and now a test breaks, and so you basically immediately found and helps you remove a defect. The different levels of testing, unit testing should be the first one. This is running code completely in process, no cross-memory, cross-process boundaries on those tests. Then a test suite for component level integration testing in between processes, like from your main core of your application, maybe out to a data store, and making sure that those round trips are happening. That would be an example. And then the third level is full system acceptance testing. This is a fully deployed instance of your software, running it as a user would run it. And then, depending on your system architecture, others might be applicable, like automated security scanning or performance testing or high load capacity testing or failure resiliency testing. You kind of force one of your components to crash or go offline and make sure that the system resolves itself and doesn't crash in total as an overall system. So that's testing. And there's so much information out there that and good tools, you want to have testing in place. Then the third one that you have to have in place is inspections, formal inspections. And this is lesser known, but the research data shows that it makes a huge difference. And these 3 defect removal techniques put together reliably push a team up into the high 90s of defect removal efficiency, according to the research. And so in today's day and age, not most people, I would say what we recommend that most people do is integrate code changes through a pull request process. And as you're evaluating a pull request from a feature branch into the master branch, put in place a checklist by which you evaluate a pull request and choose to approve it or reject it. Instead of just leaving it up to personalities and whatever someone wants to choose, as a team, put a team standard in place, a standard checklist, and put the important things on the checklist. And when someone hits that approve button on the pull request, they are affirming that the changes represented in here pass every item on your checklist. And if you need help in a candidate checklist for that, just send me an email. I'd be happy to share that with you. But implement formal inspections by putting a checklist on the pull request approval process. And that is the perfect implementation for a formal inspection to get the benefit of that. Well, I know this is a lot and this is fast, but I hope this has helped you understand that quality comes first. Only then do you have the hope of achieving stability in production, and only then will you be able to be set up in your team to achieve the productivity that you probably strive for. And you can have great developers on your team, but it's your job to organize their efforts to produce results. You can do it. You have what it takes. You are an architect. Your team is counting on you to lead. You can do it. Now go do it. Well, that's a lot of information packed in there, and I hope this helps. This has been an episode on how to set a foundation of software quality. You are an architect. You are in charge of leading a team of developers, and it's a big job. You can do it. Quality comes first. Remember that. Quality is not second. Coding is not first. From a brand new code base, brand new team, brand new code base, brand new project, put your quality foundation in place first. Static analysis, testing, inspections, from the first line of code, from the very first commit of just the basic Visual Studio solution structure. And of course, to get your test-driven development tests running, you need your automated build, you need continuous integration. We're going to go deeper into those a lot, but from a mindset perspective, you have to put in place your foundation for quality first. Then you get to your production practices, which we'll cover next time. You achieve stability running your software in production. And only when you have those two in order can you hope to achieve the productivity that you want and have your team moving at the speed that you want. If you don't have those in place, then a significant amount of your capacity that could go to productivity is spent finding and fixing defects, troubleshooting problems in production, why weird things are happening in production that are not happening in your UAT environments. You don't need that. And so quality, then stability, then speed, in that order. Quality comes first. And it doesn't matter where you are, even if you have an existing system, an existing team, start evaluating your quality foundation now and start filling in the gaps. You will see the rewards very, very quickly. So I hope this helps. Thank you for programming with Palermo, and God bless.
You've been watching Programming with Palermo, your primary place for highly productive programming protocols and practices. Remember, you have what it takes. You can do this. You are a programmer, formed by God Himself and called to this profession for a purpose. You can catch every episode at palermo.network as well as syndicated locations nationwide. We're so glad you tuned in. Until next time, may God bless you, and thanks for Programming with Palermo. Programming with Palermo has made a special arrangement with Marketplace Chaplains. Besides programming challenges, we all face issues in life where we need some help. If you'd like, you can call a chaplain confidentially. To speak with a gentleman, dial 512-923-8178. Or to speak with a lady, dial 512-619-6950. The show won't know you called, and everything is kept in strict secrecy. This is a free service, available if you or a friend need it.